Hello viewer, you are watching LM TV. Welcome to FORM1 Physics, Lesson 5, and we are still discussing Measurement 1, and today we focus our discussion on estimation of quantities. So we want to discuss what quantities are and how we can be able to estimate these quantities. So I'm going to be your teacher, Benjamin K. Makanda. Follow me up in this lesson. Now, we want to begin our lesson by looking at the lesson specific objectives, and this is how we are going to start. So our lesson objectives are as follows. Specific objectives: by the end of this lesson, the learner should be able to estimate density. So this is the main objective of the lesson. Once we are done with this lesson, you as a learner should be able to estimate density. I know you will be able to define what density is and then use the definition to be able to estimate density using the formula that is available. Now, our lesson is going to follow the following order. That is lesson preview. So in our lesson, we want to have a quick review of lesson 4. And in lesson 4, we looked at various parameters that are used in measurement 1. We discussed volume, area, length, and also density, not forgetting mass. Now, because we are going to discuss density, we related density as mass per unit volume of any given substance. So in summary, lesson 4 was actually focusing on the basic physical quantities that are used in measurement 1. And just to highlight them, one of them was mass, we have time, we have temperature, we also have thermodynamic pressure, we also have density, which is now a derived unity of mass and volume. Now, in this lesson, we are going to discuss or estimate density. We want to estimate what density is. After we have learned how to estimate density, we'll therefore look at some of the questions that will help us get to understand the various aspects that we have learned in this particular lesson. So that will end by having an assignment. Now, let's begin our lesson, and our lesson begins by focusing on density. So what is density? Density is defined as mass per unit volume of a substance. So when you take mass of a substance, then you divide by its volume, then what you get is what we call density. So it's mass per unit volume of a substance. Let's go back to our lesson number 4. Mass is a basic physical quantity. Therefore, the SI units of mass is in kilogram. Volume is a derived unity, and therefore, volume is being a derived unit of length. We can get volume by taking length into length into length. That is maybe meters into meters into meters 3 times. So that one becomes cubed. So our density becomes kilograms per meters cubed. We take kilograms for mass divided by volume, which is meters cubed. So at this particular point, given that density is the mass per unit volume of a substance, it therefore follows that the SI units of density are in kilograms meters. Now, we have a specific way in which we express density. So density of a substance is symbolized by rho, and this is the symbol of rho, and its SI units are in kilograms meters cubed. How do we get the kilograms meters cubed? You take mass in kilogram, divide by volume in meters cubed. Therefore, SI units of density is in kilograms meters cubed, and we have said we use the symbol rho to stand for density in most of the calculation. Now we have this formula here: density equals to mass divided by volume. So this one becomes the formula that can relate density, mass, and volume. So if you have this formula and you want to relate the 3 quantities, density equals to mass over volume, then the other way, mass equals to density multiplied by volume, and also volume equals to mass divided by density. So you have to relate those 3 quantities. So that's how we relate density with mass and volume. Now, to help us understand this, we want to look at an example so that we're able to employ this formula in the calculation. So the following stage, we want to look at how we can be able to apply that relationship in a mathematical problem. So we proceed on. We have example 1, and in this case, this is the problem that we have. A block of glass of mass 187.5 grams is 5.0 centimeters long, 2.0 centimeters thick, and 7.5 centimeters high. Calculate the density of the glass in kilograms meters cubed. So this is the problem that we have. Before we go to the solution to this problem, just to analyze some of the information given in this problem. One, we are given the mass, and the mass is expressed in grams. But in our calculation, we have to convert this mass in kilograms. 187.5 grams must be converted into kilograms. Therefore, how many grams make a kilogram? 1000 grams make a kilogram. So we are going to divide that. Then, we are also given the dimension of the block. The block is in form of a cuboid. It has 5 centimeters long, 2 centimeters thick, and 7.5 centimeters high. So, having these dimensions, we are able to calculate the volume of this glass. So, that's going to be 5 times 2 times 7, which is going to give us units in centimeters cubed. And then, we are required to calculate this one in meters cubed. So, the volume we get here is going to be in centimeters cubed. Then, we express them in meters cubed. Then, the big question is, how many centimeters cubed make 1 meters cubed? You take 100 centimeters times 100 centimeters times 100 centimeters. What do you get? You get 1 million centimeters cubed. Therefore, 1 million centimeters cubed make what? Make 1 meters cubed. So we have already converted that. So let's go to the problem, the solution of this. This is how we are going to approach this problem. Now, our solution. Density is given by mass over volume. We have already discussed that. Density is given by mass over volume. Therefore, this is, we substitute 187.5 divided by 1000. So 187.5 was in grams. Then we divide by 1000 to convert it into kilograms. Then divide by the volume. And how do we get the volume? Volume is equals to 2.0 times 7.5 times 5.0. This one is going to be in centimeters cubed. Then we convert this volume into meters cubed by dividing by 1 million centimeters cubed that make 1 meters cubed. That's how these figures come about. Then what do we get from this calculation? Maybe you're trying it at home. So which value do you get from this calculation? Work out 2 seconds. So do you get this value here? 2,500 kilograms per meters cubed. This one becomes the density of the glass. 2,500 centimeters cubed. This one becomes our density. So basically, what we are trying to learn here is that how do we relate density, mass, and volume. So the formula itself gives you the definition of density as mass per unit volume. Actually, density is the ratio of mass and volume. Ratio of mass to volume. The ratio of mass to volume. Mass in kilogram, volume in meters cubed. And this is how we end up calculating. That was our example number 1. Now, what about example number 2? Let's look at another example. And in example number 2, we want to use a solution. And in this case, we're going to use concentrated sulfuric acid. So this example 2, we want to employ or use concentrated sulfuric acid. So we have the problem here. The density of concentrated sulfuric acid is 1.8 grams per centimeters cubed. Calculate the volume of 3.1 kilograms of the acid. So I will go through the question once more. The density of concentrated sulfuric acid is 1.8 grams per centimeters cubed. Calculate the volume of 3.1 kilograms of the acid. One thing you realize in this problem is that the density has been expressed in grams per centimeters cubed, but the mass given is expressed in kilograms. So what you have to do first, you have to convert these units so that you use universal units. You can either choose to use grams per centimeters cubed, then you convert kilograms into grams, or you change the density into kilograms per meters cubed, so that by the end of the day, you work out with the SI units of density. So let's look at how we are able to solve this problem. Now, the solution to this, we have density. Volume is equal to mass over density. This is what we're supposed to calculate because we have been given the density. So volume is given by mass of sulfuric acid, sulfuric 6 acid. We don't just call it sulfuric acid, it's called sulfuric 6 acid in chemistry. Divided by density, this one is going to give you 3,100 divided by 1.8. So the mass that was given in the question was 3.1 kilograms. So we have chosen to convert all of them into grams. The density remains in grams per centimeters cubed, while mass is converted into grams. We take 3.1 kilograms multiplied by 1,000 grams that make a kilogram. So we get that 100 grams divided by 1.8 grams per centimeters cubed. So we have already substituted. So what do we get here? When we work out we get 1,722 centimeters cubed. This is in centimeters cubed. But if we convert this one into meters cubed, we will get 0.001722 meters cubed. I hope you understand how we are getting this on meters cubed. We take 1,722 centimeters cubed, you divide by 1 million centimeters cubed that make 1 meters cubed, and we end up with the value 0.01722 meters cubed. So this is another example that we are using in order to calculate the density of concentrated sulfuric 6 acid. We are again looking at another example, and this is going to be example number 3. Now in the example number 3, we want to use a density bottle. We have a specific bottle used in the laboratory to measure the density of substance. We call it a density bottle. So this one gives us example number 3, and this is our problem. Now, the mass of an empty density bottle is 20 grams. Its mass when filled with water is 40.0 grams and 50 grams when filled with the liquid X. Calculate the density of liquid X if the density of water is 1,000 kilograms per meters cubed. I'll go through the question once more. The mass of an empty density bottle is 20 grams. Its mass when filled with water is 40.0 grams and 50 grams when filled with liquid X. Calculate the density of the liquid if the density of water is 1,000 kilograms per meters cubed. Now, in this case, we have the mass of the density bottle. When it is empty, it has nothing, it's 20 grams. Its mass when filled with water is 40 grams. And when filled with the liquid X, it has a mass of 50 grams. Now, one thing that we note here is that the density of the liquid X is not known. So we have to use this information to calculate the density of liquid X. Though now in this case we are given the density of water, which we have to use to calculate the density of liquid X. This is how we proceed. So this is our solution. Mass of liquid is given by, now we want to calculate the mass of liquid. You get the mass, which is 50 minus 20, you get 30 grams. Now that's the mass of the liquid. You take the mass of the liquid and the density bottle, which is 50, minus the mass of the empty density bottle, which is 20, and then you will get 30 grams, which is the mass of the liquid X, and this, in this case, we get 0.03 kilograms. 0.03 kilograms. That's the mass of the liquid X. Therefore, mass of water is equals to 40 minus 20, which is going to give us 20 grams, and this is going to give us 0.02 kilograms. Then volume of water is going to be, how do you get the volume? From the relationship of density and water. Volume of water is going to be the mass of water divided by the density of water. So we know the density of water is 1,000 centimeters cubed, so we're going to have 0.02, which is the mass of water, divided by 1,000 kilograms per meters cubed, the density of water, and this will end up giving us the volume of water as 0.0002 meters cubed. Therefore, out of this, we have the volume of water as 0.0002 meters cubed. Then, volume of liquid equals the volume of water. Do you agree with this? That the volume of liquid is equals to the volume of the bottle. It's very true. The volume of that liquid and the volume of the bottle is the same. And then, because we have the volume of water, it also follows that the volume of water equals the volume of liquid X. Because the volume of liquid is equal to the volume of the bottle in which water was first confined. So, we go on. We therefore go calculate the volume of the mass of the liquid first. And the mass of liquid is equal to 50 minus 20, which is going to give us 30 grams, and this is going to give us 0.03 kilograms. And therefore, the density of the liquid is equal to the mass of the liquid, which is 0.03 divided by 0.0002 meters cubed, which is the volume of the liquid, because this volume of the liquid is the same as the volume of water, and the volume of water is the same as the volume of the density bottle, and this one is going to give us the density of 1,500 kilograms per meters cubed. Therefore, this one is the density of the liquid X. That one is our final answer to that problem. Any question up to there? Yeah, send it on the SMS number that is scrolling on your screen. Now we go on, and then we are going to look at now another area still on density, and today, and at this point, sorry, we want to look at relative density. We want to discuss what relative density is. Therefore, what is relative density? So the word is relative density. So relative from relating, you have to relate. Actually, a relative density is a density that is related to an identical density of water to that of a substance. So by definition, what is relative density? This is the density of a substance compared to the density of water. So relative density is the density of a substance compared to the density of water. You see, the word relative is relating the density of a substance to the density of water. Why we relate the density of that substance to the density of water is because the density of water is universally known. So we have to relate that density to the density of water. That's why we call it relative density. Therefore, throughout our discussion, relative density is going to be abbreviated as D. It is symbolized by D and has no units since it is a ratio. Now, relative density does not have units because you relate the density of a given substance to the density of water, and therefore the units cancels out. An example, if the density of mercury is 0.8 grams per centimeters cubed and that of water is 1 gram per centimeters cubed, then calculate the relative density of the two. Relative density equals to the density of that substance divided by the density of a given volume of water. Therefore, the density of relative density of mercury and water is going to be 0.8 grams per centimeters cubed divided by 1 gram per centimeters cubed of water. So you realize the grams per centimeters cubed for mercury and the grams per centimeters cubed for water, they cancel out and we end up having no units. And that's why we are saying the relative density does not have units because it is a ratio. It's a ratio of the density of a given substance to the density of a given volume of water. A very important thing to note here is that we symbolize relative density by a letters D small, different from density where we use rho. So don't confuse the two. So when you use D stands for the relative density. Proceeding on with the relative density. Now, how do you calculate relative density? Relative density is given by density of the substance over density of water. So you can see from the formula, relative density D in bracket is equals to density of substance over density of water. It is measured using a relative density bottle. Therefore, in our lab, we have a special bottle known as a relative density bottle that is used to measure relative density of substances. Now, having discussed that, so let's look at an example that relates relative density. So we have a problem here that we have to apply that formula. Example 4. Now, the relative density of some types of wood is 0.8. Yeah, the relative density of some type of wood is 0.8. Look at that value. Does it have units? Definitely no, because we said relative density is a ratio and therefore does not have units. Find the density of the wood in kilograms meters cubed. At this point, before you go to the solution, I have to let you know this. We have to calculate the density of the wood in kilograms meters cubed. You have not been given the density of water. The density of water is always 1000 kilograms per meters cubed or 1 gram per centimeters cubed, right somewhere there. So that any given time you get this kind of a problem, don't ask that you have not been given the density of water because that one is the standard density of water, the known density. Is 1000 kilograms per meters cubed or 1 gram per centimeters cubed. Therefore, this is how we approach this problem. So we have this density of substance is equals to D. What does D stands for? D stands for the relative density multiplied by the density of water. Therefore, the density of this substance is given by D multiplied by the density of water. So we know density of water is 1000 kilograms per meters cubed. And we know the relative density has been given as what? 0.8. So this is how we proceed. We substitute density of the substance is equals to 0.8 times 1000, which gives us 800 kilograms per meters cubed. 0.8, this is the relative density, and then 1000 here stands for the density of water. So the density of this substance becomes 800 kilograms per meters cubed. That one becomes our final solution. So that marks the end to the relative density. The other area we want to discuss now is densities of mixtures. Densities of mixtures. And before I move on to this, to discuss densities of mixtures, I just want to react to one of the questions that one of you asked. You asked, when are we going to learn about densities of mixtures? Now, this is the lesson number 5, where we are covering densities of mixtures, and I hope you are glued to your screen to be able to follow this lesson. So I'm doing densities of the mixtures. So with your pen and book, go through it, and then if you have any question, we can now socialize on our social media and also call. So what are mixtures in the first place? A mixture is a combination of two or more substances in which individual components retain their properties. Therefore, if you mix two or more components, still in physics you can be able to calculate their densities because they retain their individual properties. Just the same way you will take beans and maize and you mix them. If you pick beans, they will still have their own density. If you pick maize, they will also have their own density. And this means that we are able to calculate densities of mixtures without any given problem. Now, how do we go about densities of mixtures? We use the following formula to calculate densities of mixtures. Which formula do we use to calculate density of the mixtures? So density of mixture is given by mass of the mixture divided by volume of the mixture. Densities of the mixture is given by mass of the mixture divided by volume of the mixture. Have a pen and a paper and then pick up this example. The mass of a mixture of beans and maize is 2 grams. And they have a volume of 2 centimeters cubed. Calculate the density of the mixture. Is the mixture of what? Maize and beans. Therefore, it has a mass of 2 grams and a volume of 2 centimeters cubed. So density of the mixture is given by mass of the mixture divided by volume of the mixture. So this one is going to be 2 grams of the mixture divided by 2 centimeters cubed of the mixture. What do you get? You get 1 gram per centimeters cubed of the mixture. Very simple that way. So you know how to calculate density of the mixtures. You basically take the mass of the mixture, then divide by the volume of the mixture. And that's the end of it. So let's look at an example 5 that now relate the density of the mixtures. And we're going to use fresh water and seawater. Remember fresh water. Fresh water has a density of 1000 kilograms per meters cubed. So this is the problem that we have. 100 centimeters cubed of fresh water of density 1000 kilograms is mixed with 100 centimeters cubed of seawater of density 1030 kilograms per meters cubed. Calculate the density of the mixture. So this is the information we have. We have the volume of the fresh water as 100 centimeters cubed, the volume of fresh water as 100 of seawater, as 100 centimeters cubed, and the density of seawater as 1030 kilograms per meters cubed. So we have to calculate the density of the mixture. So this is how we proceed. First of all, we have to express the formula or identify the formula with which we are going to use to calculate the density of these mixtures. Now, we start by calculating the mass. Mass is given by density multiplied by volume. I hope we discussed this. Therefore, mass of fresh water is equals to density of fresh water, which is 1000 kilograms per meters cubed, multiplied by the volume of this fresh water, which was 100 centimeters cubed. But now we are converting this into meters cubed, so we divide by 1 million to get 0.001 meters cubed, and therefore the mass of fresh water is going to be 0.1 kilograms. Then we go on, we calculate the mass of seawater. Mass of seawater is equals to the density of the seawater, which is 1030 multiplied by the volume of the seawater, which has also been converted into meters cubed, and this is 0.001, and this is going to give us 0.10 kilograms. This one becomes the mass of seawater. What's the essence of calculating the mass of fresh water and that of the seawater? The point is simple, so that we are able to calculate the mass of the mixture. So we'll take the mass of fresh water, add the mass of the seawater. So mass of the mixture is equal to 0.1, which was the mass, or which is the mass of fresh water, plus 0.103, which is the mass of seawater, and we have a total of 0.203 kilograms. That one becomes the mass of the mixture. Now, having this, we now move on. We calculate the volume of the mixture. Volume of the mixture is given by taking the total, adding the volume of the seawater plus the volume of the fresh water. So volume of the mixture is equals to 100 plus 100, which is going to give us 200 centimeters cubed. Remember, 100 is the volume of the seawater plus this other 100, which is the volume of the fresh water, giving us 200 centimeters cubed, and this is going to be 0.002 meters cubed. So we have this. Now, therefore, density of the mixture is given by, the density of the mixture is going to be given by mass divided by volume. Density is equal to mass over volume. So our mass is 0.203 divided by our volume, which is 0.002, and this gives us the density of 1015 kilograms per meters cubed. This one becomes the density of the mixture. As simple as that. Have you understood that? I know it is yes. Therefore, I want you to apply what you have learned in this lesson to attempt this problem at your own time. So this one is your assignment for the day. So your assignment here, a tin containing 5,000 centimeters cubed of paint has a mass of 70 kilograms. If the mass of the empty tin, including the lid, is 0.5 kilograms, calculate the density of the paint, that's A. Then B, the tin is made of a metal which has a density of 7,800 kilograms per meters cubed. Determine the volume of the metal used to make the tin and the lid. So these are the one question with two bits that you will have to attempt, and all this information can be derived from the discussion that we have just had. So that marks the end to our lesson. And for questions, comments, and compliments, you can contact us by either sending your SMS to the number 22518, which is on your screen. You can also use our Facebook page, Elimu TV, and also follow us on Twitter at Elimu_KE. So up to there, I've been your teacher, Benjamin Makanda. Until next time, stay tuned to Elimu TV.